A random variable z has a standard normal probability distribution. Find the probability that z is between negative 0.53 and 1.01. All right, so again, since we know it's a z-score that we're dealing with and we know it has a standard normal probability distribution, we can draw a bell curve just as a visual aid, right? And then we have a z number line at the bottom. The center of the bell curve will be located at 0. That's the mean of a standard normal probability distribution. And it says we're looking for two values, the value negative 0.53 and 1.01. So I put these numbers on my number line in reference to 0, right? Since 0 is in the center, negative numbers are on the left, positive numbers are on the right. Now it says we want to find the area between these 2 points, so I'm going to draw a little line on my visual aid above, right? So the bell curve here above isn't necessary, but I'm drawing it there just as a visual aid. And I'm going to shade the area between those two z-scores because that's the area we're looking for. And then I'm going to pause and think about what will happen if I look up 1.01 on my z-chart. Remember that it'll always give you the area from the z-score you look up to the center, and that's all. So we won't have all of the area we want, but we will have a part of it, right? Now if I look up 0.53 on my z-chart, I'll get the area from here to the center, right? And again, that won't be all of what I want, but it's the other part that I want in the shaded region that I've drawn, right? So I'll get, by looking up 1.01, I'll get the first or right half of the area I'm looking for. And then if I look up negative 0.53 or just 0.53 because there are no negative z-scores on our z-chart, I'll get the area from 0.53 to 0, and that's what I'm looking for. All right, so let's go ahead and look those numbers up. We'll start with the first one on the left there, 0.53. Okay, so here's the 0.5 row. We need to go over to where the column says 3 at the top, and here that is right here. It's the 0.2019 value here, so 0.2019. Notice how we looked up the positive z-score because the table doesn't have negative z-scores, but since the bell curve is perfectly symmetric, the positive answer and the negative answer there would be the same, right? Remember, the area is always positive, so it's just a question of whether the z-score would be negative, and if it is negative, it doesn't matter. You can just look up the positive version of that z-score, and you will get the corresponding area that you're looking for, so 0.2019. All right, so I'm going to write that where it belongs. 0.2019 belongs here. Once again, I'll remind you that's an area. Areas can never be negative, so it'll always be positive. If you're putting an area on your drawing, even if it's on the left half of the curve, the only thing that's negative on that side of the curve are the z-scores, not the areas. All right, let's look up 1.01, see what we get there. So if you look up 1.01, here's 1.0, and then 1 would actually be here, the column that's got a 1 at the top, right? So that's 0.3438. So 0.3438. Now, how do we get the overall area we're looking for? In this situation, when you're shading across the middle and you're shading on both sides of the middle, you have to add those two together. So you're just going to do 0.2019 added to 0.3438. And then, of course, 9 and 8 make 17, carry the 1, you get 5, then 4 and 0 and 5, and there's your answer, 0.5457. So the probability here is 54.57%. And that's written as a percent. Of course, you could also leave it as a decimal, 0.5457.